Okay, so if you write it into matrix form, what are the three equations? Well, the unknowns are A, B, C, D, right? The matrix is actually not a square matrix anymore. It's a 3 by 4 matrix. The first equation, the first row, 1, 1, 1, 1, that corresponds to this. Okay, so the second row, the first row on the right hand side is 0. The second row is supposed to give me something. So let's actually move all the deltas to the right hand side and move the delta to the right hand side, which is 0. So the second is going to give me 1 over delta, and the C's and D's are going to be multiplied by minus and plus square root of 3 over 2. The third equation is going to give me 1 and minus half minus half. So let's try to construct this equation in MATLAB. So my matrix, I'll just use A again to denote it. 1, 1, 1, 1, 0, 0, minus square root of 3 over 2, and the square root of 3 over 2. The last row is 0, 1, minus 0.5, minus 0.5. Okay, so that's the matrix I have. And let's actually, because the right hand side is all scaled with 1 over delta, so if I'm actually, instead of solving A, B, C, D, what if I just multiply everything by delta, right? Delta times A, and this is just going to be times delta, so the right hand side is going to be 1. So okay, so if I just solve the equation with 0, 1, 0, I get the coefficients. Do we all know like what MATLAB is doing if I'm trying to solve a non-square system? It's actually doing least squares, right? So it's actually basically what we want, right? It's basically trying to compute the solution with the least 2 norm that still satisfies these equations. Okay, actually MATLAB does 2 different kind of least squares. If you have more equations than unknowns, it does a different type of least squares, right? It's trying to minimize the, it'll never actually get a solution, right? Because you have more equations than unknowns. So it's trying to minimize the residual of the equations. It's trying to satisfy the equations as much as possible. Here, the type of least squares is I have more unknowns than equations. So there are infinitely many solutions that satisfies the equations. And MATLAB tries to find among the infinite possible solutions the one that minimizes the 2 norm of the solution. All right, so that's the scheme we ended up deriving. And so what is this? Is this reciprocal of something? Actually, so I wonder if there is a way somebody has somebody seen this. What is this? Huh? Right. So I'm sure like if I square it, I may be able to get something. Well, it's a square root of a third, right? Okay, so basically, I know my scheme is now it's a square root of a third times WR minus WL, right? So that's what this gives me. All right. So of course this is a very simple. Sorry. So this is a very simple scheme. Maybe you can, in hindsight, maybe you can construct even without going through the whole procedure, right? Because well, what is a square root of 1/3 is actually no more than just 1 over the distance between the x distance between these 2 points, left and right. Okay, but the same procedure can be applied to more complex scenarios and even algorithmically, right? So you can actually derive, you can ask the computer to derive finite difference schemes for you at every single grid point, even if you have an unstructured mesh. Even your mesh is actually have different topology at every grid point. At this point, I have 5 neighbors. At that point, I have 7 neighbors, and all my neighbors are different distances away from me in different directions. I can just solve one of these least squares problem at every grid point, and that will figure out what finite difference schemes should I use at this point. And the coefficients, like these coefficients, can be stored algorithmic. Wait. I think. Oh yeah. Okay. So yeah. So these coefficients can be stored at each grid point and used for the finite difference. All right. Any questions on this?